Hello everyone, I am Prem Kumar. Welcome to Math JEE Academy. Today I am going to discuss with you very interesting topic. Before entering into the topic, I am going to tell about my channel. This Math JEE Academy is completely for JEE aspirants. You can see the list of playlist, Mathematics, JEE Main, Mathematics JEE Advanced level problem series would be there. Day wise would be there. You can access the video, and then coming soon I'm going to release the subtopic wise problems concept. For example, how to find out the number of onto functions, how to find out the number of one functions, those kind of questions would be there. So I know that some of the areas the students are facing problems. I'm just collecting all kind of in my experience I'm going to release the subtopic wise concept soon. And then fourth thing is you can find out the shorts within the 1 minutes. The shorts would be there. You can access all the shortcuts tricks for JEE Main and Advanced. Okay, let me begin with the topic. Today topic is how to use graph to solve advanced JEE problems faster. The first question is, here is the maximum of 1 minus x, 1 plus x and 2. 1 minus x, 1 plus x are linear functions, 2 is the constant functions. How to choose this maximum of these three things? Okay, first let us understand the students are facing difficulty here is how to plot the graph. First understand through the graph, right? So what you can do, first 1 minus x, 1 plus x and 2 you can take. Just where these graphs are intersecting, first you can find out. 1 minus x, 1 plus x into 2 and the first and last. Just your combination you can take. 1 plus x is equal to 1 minus x. Okay. Then you can solve this quickly. 2x equal to 0, x is equal to 0. This is one critical point. And then if you take the second and third, 1 plus x is equal to 2, x is equal to 1. This is another critical point. And first and last you can take 1 minus x equal to 2, 1 minus 2 is equal to x, x is equal to minus 1. So these are the critical points. Let's take number line minus 1, 0 and 1. So first identify where this function is breaking. Once you find out, then what you can do next thing, you have to analyze the interval. Suppose if x is less than minus 1, you check the behavior of each of the functions, right? Let me begin with 1 minus x. So required, no? So first you multiply by minus 1 on both sides here. Minus x is greater than 1. Add 1 on both sides. 1 minus x is greater than 2. Y is greater than 2. Let me take the 1 plus x. What is that? Just adding 1 both sides. What will get? 1 plus x less than 0. Y should be less than 0. And third one is y is equal to 2. Among these three things, you can see this is the first one, this is second one, this is third one, right? Among these all three, which one is the maximum here? Y is greater than 2. So this is the maximum you can choose here. Okay, so then you can see f of x, how to redefine this. If x is less than minus 1, the maximum will be 1 minus x. Okay, and you can see minus 1 to 0, 0 to 1, both will be same only. So we can take the whole interval. Next is x is minus 1 to 1. In this interval, you have to check the 1 minus x and 1 plus x combination, right? So you can add 1 both sides. For example, 1 minus x, we need to multiply minus 1 on both sides. 1 is greater than minus x is greater than minus 1, right? So you rearrange it, minus 1 less than minus x less than or equal to 1. Now add 1 both sides, 0 less than 1 minus x is less than. So you can see you're adding 1, right? It is 2. So 0 less than y less than 2. Let me begin with 1 plus x. 1 plus x, you can see, you can, in this interval, so x will be there, you can add 1 both side. So what will get? 0 less than x plus 1 is less than 2. So here also y will be 0 to 2. Okay. So next is y is equal to 2. You can see we have to take the interval minus 1 to 1 in this interval, which is the maximum here. Y is equal to 2. If minus 1 less than x less than 1, which is the maximum here, 2, right? And one more thing, if you take x is greater than 1, so obviously one more function is there, that is 1 plus x. That is, if x is greater than 1, this is your function, right? How you can check the differentiability? Just you can differentiate algebraically. How to solve this? Just differentiate this function. You can check the limits, right hand derivative and left hand derivatives are same or not. This is algebraically, you can do it. But how to draw graphically? You can see this graph is very simple, right? When x is less than minus 1, you can break the interval minus 1, 0 and 1 here in this interval. So minus x plus 1 is there. You know, minus x graph, you know, which is passing through the origin. It's negative slope, right? You just shift 1 units up. If you put minus 1 here, it will be 2. So it will be 2 here. The graph will be like this. When you take minus 1 to 1, the constant function y is equal to 2, right? Let me take another color. Yes, y is equal to 2. Okay. If you take x is more than 1, y is equal to x plus 1. Y is equal to x plus 1 is the, passing through the origin, which is, positive slope. Then you can see if you put 1 here, you will get 2 minimum. This is the graph. This is your original graph. How to check the differentiability? You can see this corner point, minus 1 and 1. It is not differentiable. Why? This is sharp edge is there. So this is not differentiable at minus 1 and 1. You can check through the graph. There is no break. There is no break anywhere in the domain, right? So definitely the function is continuous. Therefore, the first option is continuous at all points is correct or not? Yes, correct. The differentiable at all points or not? No, this is not correct. Differentiable at all points except 1 and minus 1. Yes, correct. Continuous at all points except 1 and minus 1. No, continuous at minus 1 and 1. So because there is no gap in the curve, right? It's a continuous. There is no differentiability at x equal to minus 1 and 1 because there is a sharp edge. If you approach from right and left, there are different functions. If you approach, you can see, if you approach this direction, you can see this different function. If you approach this direction, you can see different functions. The right hand derivative and left hand derivatives are different here. Therefore, this function is not differentiable at minus 1 and 1. Rest all the points is differentiable. Differentiable all points except at 1 and minus 1. There are two options is correct, continuous at all points in this interval, and second thing, differentiable at all points except at 1 and minus 1. So thank you everyone, and if you like this video, you can subscribe it, like it and share to your friends. Thank you everyone.